talk about tangent properties. Now, tangents are parts of circles, so we're going to be kind of going over that. I'm giving you this right here. So we have a list of terms. These are terms that we've used before. It's been a while. And we have a list of figures right here, including arcs, angles, segments, looks like some lines and some circles. So what I want you to do is I want you to write down those 10 terms and write down the letter that matches up with them. You need to turn this in before the end of the period. So that way I can tell you've actually watched the video and you're actually paying attention to the words that I'm saying. Now, if you forget to do this, you might lose some points. So make sure you do this before the end. Okay? Look, here we have a line that touches a circle on one point. Okay, so you have O is the center of the circle, T is the spot of tangency, we call it. So we say that a tangent to a circle is perpendicular to the radius. So perpendicular, if you forgot, it means a 90-degree angle. So that means right here, there's a 90-degree angle. So you see that little red box? It means 90 degrees. So if you see that box, it means it's a tangent. If you see the tangent, you can write the box so you know the degrees. That could be helpful when trying to find out missing angles. Also, when you have two tangent lines that hit a circle, so NA and NG are two tangent lines. They hit at points G and A. So there's two radii, EA and EG. When that happens, the segments are the same. So you'll notice the two red lines, AN is equal to NG. So that'll be important later on down the line. Maybe not as much today, but you should make sure you know that those are equal. Now our next thing, when we talk about circles and tangents, sometimes you can have multiple circles that are tangent to the same line. Now you have two terms here, internally tangent and externally tangent. Internally tangent means that you have a circle within each other. They just both happen to be kind of like off to the side, like one end of the other. Externally tangent circles are two circles separated each other, but kind of touching with that one line that goes in between them. Now, it's important to know that in externally tangent circles will have two separate radii, or radius. In internally tangent circles, we'll have a radius on top of one another. So you need to make sure you know the difference between the two. Now, if the radius is on top of one another, that might make a difference in terms of how big the radius is. Still, no matter what, all the angles of the tangents are 90 degrees. So let's look at an example right here. In this figure, TA and TG are both tangent to circle N. So you see this figure here, so TA, TG, are those equal tangent lines. If the major arc formed by the two tangents measures 220 degrees, we want to find out what angle T is on the left. Now, one of the things you should always remember, circles. How many degrees are in a circle? Well, you should know that they are 360 degrees. For every circle, no matter the size, no matter how big, how small, every circle is 360. So if on the right, from A to G on the right is 220, the opposite side of the circle is 360 minus 220, which in this case is 140. Now this is important because this helps us figure out our central angle, ANG. Now the arc that's on the outside and the central angle are always equal. So that means this is 140 degrees. This is going to be helpful in solving this problem. Now you should notice NA and NG start at the center of the circle. They're like a radius, and they hit the tangent lines, which we know because they told us in the problem. That means that you have 90-degree angles here and here. Okay, so that's really important. Now, if you look at the figure TANG, tang, it's a four-sided figure. Now, four-sided figures means you have four angles. Four angles means it's 360 degrees. That means angle T is 360 minus the 140 that's in the middle, minus the two 90-degree angles, which gives us a grand total of 40 degrees. So in some of the problems, you're going to have to find missing angles. You'll have to use the properties that we've learned today in order to put those where they need to be, and then you'll have to do probably some either addition or subtraction to figure out the answer. Let's try one more example. So in this example here, I've got a circle. Looks like I got a couple triangles here with some radii. You have a tangent line that's at the bottom, knowing that that's a 90-degree angle. I've got this red arc that's 245 degrees. Now we just learned in the last slide, if I know one side of the circle is 245 and the circle has to be 360, that means the bottom part of the circle, which is in black, that's including both sides of the kind of triangle there, that's got to be 115 degrees. Now, if that's 115, that means this angle right here in the center is 115. That means if I look at the big triangle with the 35 degrees, now I got 115 that kind of encompasses both those angles there, and I have X on the right. Well, a three-sided figure, if you remember, that's called a triangle. A triangle adds up to 180 degrees. So that means I would take 180 minus 115 minus 35 equals 30 degrees. So you're going to see how we're still using triangles. We're still using the shapes that we've learned in the past, angle sums, in order to help us find missing angles. Now we just have a few more tangent properties to help us out. But always remember, circle's 360. Make sure you follow the directions on each of your problems. Make sure you look for the assignment on Google Classroom. And then don't forget to turn in that quiz.